says that an alien with technological intelligence has to be just like us. The divergent evolution. One of the main lines of thought in contemporary astrobiology is that extraterrestrial intelligent life will be very similar to us in many ways, especially when higher levels of organization are considered. This is because the processes that give rise to life are assumed to operate independently of the environment, and also because physics severely limits the variety of feasible options. Therefore, the probability that intelligent life is evolving elsewhere in the cosmos may be very high, although the probability that it is humanoid in type may be very low. The truth is that we know very little. For example, we do not know if Earth was the lucky winner of a cosmic lottery or if life has appeared elsewhere in the universe. We do not even know if a hypothetical ET would follow the same laws that we know on the only planet that definitely supports life. There is little doubt that physical and chemical laws apply throughout the universe, but there is not the same certainty about biological laws. Frankly, if we were to encounter life on another planet, we might not even be able to recognize it. In short, our first contact with advanced aliens might be a blow to our self-esteem as we face, who knows, a more intelligent species than our own. But if that first contact ever happens, we should be prepared for another twist. The aliens may be so different from us that they won't even realize that we are sentient. At first glance, trying to imagine the physical appearance of a technologically advanced extraterrestrial seems like an absurdly impossible task. For one thing, we don't even know if intelligent beings of extraterrestrial origin exist, let alone what their home planet might be or what their morphology might be. Our challenge is therefore limited to using what we know about the evolution of intelligent life on Earth, considering possible extraterrestrial planetary environments, and making a series of reasonable assumptions. The two views. The disagreement about the likely appearance of intelligent extraterrestrials is divided into two opposing positions. On the one hand, some take a more anthropomorphic view of ET and believe that it would be essentially humanoid, with 2 arms, 2 legs, a head on top of the body, and the major sensory organs located on the head. On the other hand, some exobiologists believe that intelligent ET could appear in a completely exotic form because the creature would inevitably have followed an evolutionary path completely from that of humans and would have arisen in a planetary environment very different from Earth. The anthropomorphic view. Many scientists believe that aliens may not be so different from us, and to support this hypothesis, they usually cite a well-known phenomenon called convergent evolution. Essentially, species exposed to the same environmental pressures tend to develop similar anatomical features through natural selection. This is why a mammal like a dolphin looks similar to a cartilaginous fish like a shark. Even a creature that evolved and lived in the liquid ocean of a distant exoplanet would probably evolve a fish-like form to move quickly. After all, the laws of physics are the same here as they are on the other side of the galaxy. According to proponents of the humanoid form, speculation about ET morphology must take into account what happened here on Earth, where it was in an aquatic environment that organic matter based on carbon compounds began to develop. And it was the first marine creatures that developed the characteristic that would determine the future form of Earth's inhabitants, that of bilateral symmetry in body shape. This form, in addition to being the most economical in terms of genetic programming, minimized resistance and turbulence in the water and became the characteristic of all marine creatures, then transferred to terrestrial animals. Proponents of the humanoid form also argue that intelligence, as it is tied to the use of tools, can only arise as an evolutionary adaptation among terrestrial species. The use of tools by marine creatures would be extremely difficult due to the density and viscosity of water. Moreover, it seems likely that intelligence can only arise in predators. What about birds? Well, there are some really intelligent ones, like the crow, for example, but for an alien in the form of a bird to build tools and develop a technological type of intelligence, it would need appendages similar to ours: arms, hands, and fingers, which is obviously incompatible with an animal that uses its upper limbs to fly. Yes, because the development of legs, arms, and grasping appendages is a delicate evolutionary step on the ET's path to intelligence. Hang on a sec, guys, before we continue. Be sure to join the Insane Curiosity channel. Click on the bell. You will help us to make products of even higher quality. Primitive technology requires the ability to hold and manipulate basic tools and weapons with a certain degree of sensitivity, such as clubs, spears, knives, and tendons for bows, and the ability to combine all of this with movement speed. Otherwise, our ET runs the risk of remaining forever confined to their comfort zone and never being able to travel around the galaxy aboard a spacecraft. The issue of the number of limbs is one of the most controversial when discussing the morphology of intelligent ET. The 4 limbs we have are the product of genetic inheritance from our earliest mammalian ancestors, which was in turn inherited from fish with 4 fins that ventured onto land. But is there an optimal number of limbs? Well, a single limb would obviously be completely useless. For strictly mechanical reasons, 3 points are geometrically required to define a surface plane. 2 points form only a line. ETs trying to stand on only 1 or 2 levers will promptly fall face down. We humans can remain upright only because our large feet provide additional points of contact with the ground. But without fingers or toes, at least 3 legs are necessary. Are tripod aliens possible? Traditional biologists say no. A 3-legged creature must lift at least 1 limb off the ground, at which point it loses its planar support base, a statistically unstable and dynamically precarious situation. 4-legged creatures seem better from an engineering standpoint, since the creature can remain balanced when 1 leg is in motion. Ancestral fish only had fins in pairs, so should all limbs evolve in pairs as well? Xenobiologists are not convinced. Most running birds and quadrupeds keep 2 or fewer limbs on the ground during locomotion, so dynamic 3-point stability is probably unnecessary. Terrestrial life need not always evolve from fish, even with fins. The descendants of a starfish, for example, might have an odd number of legs. More than 4 legs are also plausible for massive, intelligent animals. Odd appendages are often used for highly specialized purposes, such as the prehensile tail of monkeys and the flexible trunk of elephants. The key to superior multipedia is neural control. The neural circuitry for an extra limb is far less than that needed to add, say, another eye. Muscles require thousands of new neurons, but eyeballs require millions. About 1/3 of the mammalian brain is devoted to sensory functions, while only a small fraction is devoted to motor control. Aliens are much more likely to have extra arms than extra eyes or ears. As we mentioned earlier, vertebrates on Earth have 4 limbs only because they share a common ancestry with 4-fin fish. Had we instead evolved from Euthacanthus, a Devonian fish with no less than 7 pairs of fins, we might be hexapods or even heptapods today. After all, there are many advantages to living on 6 legs. On high-gravity worlds, hexapods are a good way to distribute mechanical stress and reduce the risk of bone fractures. Injury or loss of a limb is more catastrophic for 4-legged humans than for 6-legged humans, who have spare limbs. Hexapods also have better balance because, unlike quadrupeds, they can maintain a stable supporting tripod on the ground even at high speeds. And it should not be too difficult to coordinate all those legs. In short, according to mainstream biologists, there seemed to be no escape from the dictatorship of the principle of evolutionary convergence. The exotic forms invoked by some astrobiologists may exist, yes, and may be the most common, but the point is that they are not evolutionarily plausible, nor can they explain how they could have achieved technological intelligence in the absence of the most basic manipulative skills. Exotic biology. However, many scientists argue that there is very little chance that an alien life form could remotely resemble us, given all the possible variables that could make a difference, such as environmental ones, referring to the particular geological, atmospheric, and meteorological conformation of the planet. Physical ones, first and foremost, the force of gravity, which is different from Earth's. Planetary ones, example, a habitable planet could have a more complex orbit and spatial geography than Earth's, and biological ones related to the evolutionary process and natural selection. One possibility often suggested by more radical exobiologists is that extraterrestrial life may depend on the chemistry that does not require the carbon atom. Although carbon chemistry is undeniably the optimal chemistry on planet Earth, one can hypothesize that biological life is built around silicon, which is very common in the sand and used specifically to make electronic circuits. This could affect the body structure of extraterrestrials, as they may require different types of proteins, enzymes, nucleic acids, and other cellular components. For example, an alien might have very thick, tough skin to protect itself from radiation, or a completely different vascular system to transport nutrients and oxygen throughout the body. In the 1960s and 70s, the famous astronomer Carl Sagan was convinced that technologically advanced species could evolve indifferently on land, sea, or air, with unimaginable chemistry, shapes, sizes, colors, appendages, and opinions. This in turn influenced the science fiction of those years, which began to imagine non-humanoid or even decidedly exotic life forms, such as sentient clouds of interstellar gas thousands of kilometers in diameter, or bizarre balloon-shaped creatures floating in Jupiter's gas belts, using a hydrogen-based metabolism instead of oxygen. Some suggest that extraterrestrial intelligent beings might resemble insects, birds, fish, or even plants. They could have a spherical shape, be sticky jellyfish-like creatures, like the heptapod beings proposed in the movie Arrivals, or even exist as a planet-sized ocean intelligence like the one in Stanislaw Lem's novel Solaris. But old-school biologists shake their heads and ask, how could these creatures have become intelligent? They seem to us to be only fanciful hypotheses, without the slightest relation to physical and biological laws. And to this, the exobiologists reply that if the goal is to scientifically hypothesize intelligent alien life forms, then it is necessary to abandon all anthropocentric preconceptions and accept creatures that differ from us in every parameter. The principal convergence is a popular one in the field of evolution, it is true, but it would hardly be able to reproduce all the physical characteristics familiar to us in creatures scattered over billions of other distant worlds. True, we won't have an answer for many years, decades, or even centuries, but it's still nice to talk about it and to anticipate issues that will affect our great-grandchildren very closely in the near future. And what do you think? Are you on the side of the old biologists or on the side of exobiologists?